In this video, I am going to explain the 4 key principles of object-oriented programming language. These are the 4 key principles: the data abstraction, encapsulation, inheritance, and polymorphism. I am going to explain them one by one. The first one is data abstraction. In real life situation, you might have noticed that you need not require to know the details of the technologies to operate the system or a device. For example, take this switchboard. When you on a particular switch on the board, it may glow a bulb or rotate a fan. You are not bothered about how the wires are connected in the switchboard to make the bulb or fan operational. Similarly, in object-oriented programming approach, only the essential information about the data is known to the outside world. The background details or the implementation of code are hidden in order to reduce the complexity. This act of representing the essential features only to the outside world without knowing the background details is called data abstraction. For example, a program can make a call to sqrt function to calculate the square root of a number without knowing the algorithm of the function. Now, let's move on to the next principle, that is encapsulation. In my previous video on object-oriented programming, I already told you that the data and the methods are grouped or merged together in a particular block of a program, that is object. This grouping or joining is done in such a way that the data items are only accessible within the functions of the same object. This wrapping of data and methods of an object as a unit is called encapsulation, so that they can be used together for a specific operation. Now, let us suppose we have another part of the program called the main function. Now, the function of an object can only access the data items. If you try to access the data members from this function, it will be restricted. The data can be only accessed through the methods. So this is the essence of encapsulation, in where the data and methods are grouped together and the data is accessible only to the functions inside the method, inside the object. It is not accessed directly to the outside world or outside the class premises. Now the next principle of object-oriented programming is inheritance. Now first of all, what is inheritance? The inheritance is a mechanism in which one class acquires the feature of another class. The class that is inherited is known as the superclass or base class or parent class, and the one that inherits from the base is known as subclass or derived class or the target. Let's understand it with the help of a real world example. Consider a family. In a family, a child inherits characteristics from parents. So, these parents are the base class and this child is the derived class. So, the child shares the characteristics of their parents. In the same way, in the programming world, sometimes we may need to create multiple classes to meet our need. So, under such circumstances, it may happen that some of the features of one class are shared by another class. So, let's take an example of the real world example. In this given illustration, shapes is the base class, whose features or whose properties, that means the data members and the method members, are shared by these two derived classes, 2-dimensional and 3-dimensional, in order to calculate perimeter, area, etc. of different shapes. So this is the essence of inheritance, in which the features of the parent class or the super or the base class can be reused inside the derived classes in order to perform some other task. And this phenomenon is called reusability, and it leads to the less time in writing a program, it takes less storage space in the memory, and it makes the execution of the program faster. So the properties of the base class are shared by the derived classes. The derived class can modify them according to their own need, but the code that need not to be written once again. So inheritance promotes reusability. Now the last key principle of object-oriented programming is polymorphism. Now what is polymorphism? Poly means multiple, morphism means form, so multiple forms. So first let's make it clear with the help of a real world example. Consider this term cell. This term cell has different meanings according to different aspects. The term cell in physics refers to a device which supplies current in the electrical circuits. In biology, it is the fundamental structural and functional part of a living being. The same term referred to a portable telephone, and also it refers to a room in a prison in which a prisoner is locked. So, a single term is used for multiple reasons with different meanings. That is the same case with object-oriented programming. In object-oriented programming, an object may include a function that can be used for multiple operations. Take the example of this function, volume. This volume can be used to calculate volume of a cube, which will take side as its input. The same function volume can be used to calculate the volume of a cuboid, and then it will take length, breadth and height as its input. So the same function is used to calculate the volume of different shapes with different inputs. Now using a single function to carry multiple tasks is said polymorphism. So these fours, abstraction, encapsulation, inheritance and polymorphism, these fours are the key principles of any object-oriented programming. I hope it will understand, it will clear for you. That's all for this video.